In our last lesson, we learned how to calculate probability for a simple event, such as flipping a quarter. We know that probability is winners over total, or winners over sample space. Now, if I flip a coin, there are two possibilities. It either lands on heads or it lands on tails. If I want it to land on tails, that is my one winner, and I have two total. So I have one winner over two total, which gives me a probability of 1/2. Simple enough. But what if I don't just want it to land on tails once? What if I want it to land on tails 3 times? I take out my quarter and I flip it, and tails, flip it again, tails, flip it again, tails. That probability seems less likely that I would get tails 3 times in a row. But how do we calculate exactly the chances? What if I pull back my die that I had last time, and this time I want it to land on a 3? To calculate its probability, simple enough. Right? There's 1, 3, 6 total faces. 1/6 would be my probability. But what if I want that 3 4 times in a row? That seems less likely than just the first time, but how do we calculate its exact probability of me taking out 4 die and them all landing on 3s? Or rolling the same die 4 times and it landing on 3 each time? Well, in order to calculate these multiple probabilities, we just use the same logic that we used in our first example. So let's go back to that. In order to calculate a probability of landing on tails, I said there is one winner out of 2 total options. And remember, we call our total the sample space. So in order to figure out the probability of 3 tails in a row, we just need to calculate how many winners and how many total options there are. So let's start with the first one. The picture you see right here would be tails, tails, tails. Now I could also flip tails, tails, then heads, or I could flip tails, heads, heads, or tails, heads, tails. I could also do heads on the first one, and then do 2 tails, or heads, tails, heads, or 3 heads in a row. These are all the possible options. This is my sample space of flipping that quarter 3 times. Those are all the different options or possibilities of what could happen. How many of them are winners? This first one right here. It's the only one that is 3 tails in a row. So my numerator would be 1. And how many total do I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 total. 1 over 8, or 1/8, would be my probability. Now this seems like kind of a long way to calculate it. Since we're dealing with multiple probabilities and our sample space is increasing exponentially, you noticed it went 2 here all the way up to 8 here, what we're going to do is simply multiply the probabilities of each event. And we'll see if we get the same answer. So the probability of landing on tails for this first time is 1/2, right? What's the probability of landing on tails this time? 1/2 still. And the probability of landing on tails this time, still 1/2. 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. Probability of 1/8. Because your sample space is increasing exponentially, you simply multiply the probabilities of each individual event. These are all the individual events. And you're multiplying them together to get the probability of them happening together. Multiple probabilities, you simply multiply their individual probabilities. Pretty straightforward. All right, let's see if we can apply that same logic to our example about the die. We said the probability of getting to 3 the first time is 1/6. Now this sample space is going to be significantly larger than my example with the quarters. Why? Because I'm already at 6, and we said that it increases exponentially. And I want to find out how to get a 3, what the probability is of getting a 3 4 times in a row. So rather than drawing out all of the different sample spaces over here and wasting all our time, we're going to apply the formula that we learned with the quarters. So what's the probability of getting a 3 the first time? 1/6. And the second time, 1/6 again. Third time, 1/6. And the fourth time, 1/6. Because nothing changes with the die. Each time you have a die, the probability of you rolling a 3, unless you're dealing with loaded dice, is simply 1/6. So we multiply these 4 probabilities together. Our numerator is 1. There is only one winner in our sample space. And then we're going to do a little bit of math to calculate our denominator. 6 times 6 is 36. 36 times 6 is 36. 216 times 6 is 1,296. Which is also the same thing as 6 to the 4th power. Because we're increasing our sample space exponentially. From 6 to 36 to 216 to 1,296. Pretty straightforward. You calculate each event's probability and then just multiply them across. There's one other thing we need to clarify before we move on and you do your examples by yourself. Here's the Skittles example from the last lesson. Now, when we were dealing with the quarters and the die, those events don't change. They're independent of each other. Independent. The probability of landing on tails is simply 1/2. Just because you landed on tails the first time, that's not going to change it the second time. It's still 1/2, and then 1/2. Independent means the sample space does not change. The opposite would be dependent, which, as you might guess, means the sample space changes. So, here I have a group of Skittles. And I'm going to reach in and grab a green one. And then I'm going to eat it, because that's what you do with the Skittle. And after that, I want to grab a red one. And eat it as well. What is the probability that these two events occur? That I grab a green, I eat it, and then I grab a red. Okay. First step, obviously, calculating the probability of getting the green. So there are 2 greens out of 1, 2, 3, 4, 5, 6, 7, 8, 9 total Skittles. 2 out of 9. Okay? Straightforward, we did it last time. Now, what is the probability of me getting a red? How many reds are there? 3. How many total Skittles do I have? Not 9, because I ate one of these greens. That's gone. It's not back in the sample space. So how many do I have left? 9 minus 1 is 8. So my probability is 2 times 3, which is 6, over 9 times 8, which is 72, which I can then reduce to be 3 over 36, which would be 1 over 12. My probability is 1/12. That when I reach in, blindly grab a green, eat it, reach in, grab a red blindly. Okay. The difference here between the dependent and the independent is that the sample space is changing. My denominator went from 9 to 8 because I ate one of the Skittles. When I have a die, I can't eat one of the sides. That sample space is not going to change. These are problems that you need to be more careful when you're trying to complete them. Make sure you pay attention to your sample space. Now is your turn, and good luck.